Hello. Today we're going to talk about 3.4 higher order derivatives. When you take the derivative of a function, you get another function. So you can repeat this process to get the higher order derivatives of the function. Remember the definition of the derivative of function f, which is denoted by f prime, is equal to the limit of f of x plus h minus f of x over h as h approaches 0. So if you take the derivative of the derivative, you get the second derivative. So that's just the limit of f prime x plus h minus f prime x over h as h approaches 0. In general, the nth derivative of f is denoted by f to the parenthesis n, and there's some other notations, including y to the sub parenthesis n, d to the ny over dx to the n, or d to the n f, or d to the ny. So let's just do a simple example of finding the higher order derivatives of function f. The function is x to the fifth minus 3x to the fourth plus 4x cubed minus 2x squared plus x minus 8. So we can take the first derivative by using the power rules to get 5x to the fourth minus 12x cubed plus 12x squared minus 4x plus 1. And when you take the derivative of this first derivative, you get the second derivative, which is 20x cubed minus 36x squared plus 24x minus 4. And you take the derivative again, you get the third derivative of f, which is 60x squared minus 72x plus 24. And keep on doing this process, we get the 120x minus 72 for the fourth derivative of f, and the 120 for the fifth derivative of f, and the 0 for the higher order derivatives when n is greater than or equal to 6. The higher order derivatives have important applications in economy. So let's just do a simple application in inflation for the higher order derivatives. The inflation rate of an economy is defined as I prime of C over I of C, where I of C is the consumer price index of the economy at the time of t equal to C. Okay, so in this example, the function I of t, the consumer price index, is equal to a negative 0.2 t cubed plus 3t squared plus 100, and we consider t from 0 to 9 years. And that function gives the CPI, or consumer price index of an economy, where t is measured in years, with t equal to 0 corresponding to the beginning of 2004. There are two questions. Question A, we need to find the inflation rate at the beginning of 2010, which is t equal to 6. And the question B, show that the inflation was moderating at that time. So according to the definition of the inflation rate, in question A, we just take the derivative of I of t and divide it by I and plug in 6 for t. So remember, I of t is negative 0.2 t cubed plus 3t squared plus 100. So if you take the derivative of I, you get negative 0.6 t squared plus 6t. On the next slide. So at t equal to 6, the inflation rate will be I prime 6 over I 6. So plug in 6 for t in this formula, we get negative 0.6 6 squared plus 6 times 6 over negative 0.2 6 cubed plus 3 times 6 squared plus 100. And that's equal to 14.4 over 164.8, and approximately equal to 0.0874. So that's the inflation rate at the year of 2010. In question B, we need to show that the inflation was moderating at that time. So what we do is we take the second derivative of I and see what happens. So the second derivative of I double prime t is equal to negative 1.2 t plus 6 if you just take the derivative of I prime. So at t equal to 6, plug in 6 for t, we get negative 1.2 times 6 plus 6. That's just negative 1.2, so that's negative. Now, what does it mean by negative for the I double prime? It means I prime is decreasing. Okay, so that means the inflation rate is decreasing. So we can conclude that the inflation was moderating at that time. All right, so we're going to do 3.5 next time.